Hi guys, so today we're going to be learning about base E and natural logarithms. Before we get started with our first example, let's look at the textbook to figure out where we get this number. So where we get the number E actually comes from this idea of continuously compounded interest. Right? What we know, so what compound interest is how often you get paid for your interest. So here in a yearly compounded interest, you get paid interest once a year. Okay. In a quarterly compounded interest account, you get paid 4 times a year, and it also pays on top of what you were paid from the previous quarter. Right? And then this is the amount. Monthly is then 12 times, 365 is daily, and then if you were paid hourly, etc., etc. And then we can go minute, second, whatever. And so what we notice is that here in the A column, we're getting closer and closer to this number. Okay? As it says here, it's approaching this number, and this number is 2.71828, etc., etc., etc. And this number we refer to as the natural base of E. Okay. So an exponential function with base E is known as your natural base exponential function. It's shown here on the right. Okay. And this natural base exponential function is used extensively in science to model quantities that show growth, right? That exponential growth or exponential decay continuously. Okay. As a result, because of how common this is, most calculators have an e to the x function for evaluating these natural base expressions. Okay. And so that's going to take us to our first example, which is just seeing if we can enter it into our calculator. Okay. So we're going to use a calculator to evaluate each expression to 4 decimal places. Okay. So what you want to find is your E button or your e to the whatever power button. Okay. So here I have it twice. So once I have it just as E here in my red, which if I wanted to get this button, I would hit alpha. Okay, and then this button, and that will give me E. Okay. I also have it in terms of the exponent wise, e to the, and then there's this little box where I will enter my power in. And I can access this by, since this is in yellow, by pressing my shift button. Okay. So the first one is e to the second, so I'm going to hit my shift and then here to access the e to that power. So here now you'll see e, and then this little box is going to let me enter the exponent, so e to the second or e squared. And that gives me 7.3891 because I'm doing it to 4 decimal places. So e to the second is approximately 7.3891. Right? Then I'm going to do the second same thing for e to the negative 1.3. So again, shift e, and then in my power negative 1.3. Right? And that gives me approximately 0.2725. Okay. If you don't know how to enter it in your calculator, please send me an email, and then I can hop on Zoom and show you how to do it. Okay, there you go. So why don't you try CYP 1B, and once you're done, come check your answer. Okay, and you should have gotten 0.1108. Okay. Again, if you got this one wrong, please email me, or else you're going to have difficulty doing the rest of your homework for base E and natural logs. Okay? Okay, so since we know e to the whatever power, that's with our exponential function, right? The inverse would be logarithm. And so the logarithm with base e is known as our natural logarithm. Sometimes we write it as log and then base e of x. But since this can be a little bit confusing, right, it can look like the e is up here and stuff like that, we often abbreviate it to be ln of x, which stands for natural log. Okay? So whenever you see ln, it really is log base e. But just because of how messy sometimes we can write it, we do change it and abbreviate it to ln for natural log. Okay? The natural logarithmic function y equals ln x is the inverse of y equals e to the x. Okay? So this is the exponential, natural base exponential function, and this is the natural logarithmic functions. Okay, note that they're inverses because they're reflected across y equals x. Right? The asymptote changes from the exponential one is the x-axis, but the logarithmic one is now the y-axis. Okay. Note that instead of 0, 1 from the exponential and the logarithmic, it's 1 over 1 comma 0. Right? Instead of 1 comma e for the exponential, it becomes e comma 1 for the logarithmic. There you go. Okay? And so most calculators have an ln key, a natural log key, for evaluating natural logarithms. So that's going to take us to example 2. We're just going to make sure we can enter it into the calculator. So look at your calculator. Somewhere in your calculator you should have a button that says ln. Okay. So again, it stands for log base e. Okay. So here we're going to enter in ln4, so I'm just going to hit the ln button and 4, close my parentheses, and that gives me approximately 1.3863. Because of the 9, it's going to go up. Okay. So this is 1.3863. Okay. Then trying out my next one, ln of 0.05, or natural log of 0.05. So again, hitting my ln button, 0.05, close my parentheses. And that gives me 2.9957. The 3 allows the 7 to stay the same. Okay, so this is negative 2.9957. And there you go. Okay. So why don't you try CYP2B, and then once you're done, come check your answer. Okay, you should have gotten negative 1.3863. If you got this wrong, again, please shoot me an email, or else you won't be able to do any of the other problems here. Okay, you need to make sure you know how to type it into your calculator. Okay, so now, example 3 here, we're just going to be rewriting them into its equivalent exponential or logarithmic form. Okay. So e to the x equals 5. So rewriting it as a log, that would be log, right? My base is e, right, because that's what has the exponent. And then 5 equals x, right? But again, for base e here, for logs, we often rewrite as ln. So another way to say it is ln of 5 equals x. And there you go. Okay, and then so same thing here, right? The ln of x stands for log base e of x. Is approximately 0.6931. So rewriting it, this is the base. This would be the exponent. And this would be the answer. And there you go. Okay. So why don't you try CYP 3A and 3B and come check your answer when you're done. Okay, so for 3A you should have gotten ln of 6 equals x, and for 3B you should have gotten e to the 0.5352 is approximately x. And there you go. Okay, so yeah, right, because you're rewriting it as log, so log base e, answer exponent. ln stands for log base e, so e exponent answer, e exponent answer. Okay. Okay, so now we're going to take all of that and we're going to solve our base e equation. Right? So the first thing I'm going to do is get my exponent by itself. Okay, so to do that we go reverse order of operations. Right, so several things I see here. I see multiplication, exponent, and a subtraction. Okay. So since we're going reverse order of operations, I'm going to get rid of the subtraction first. So opposite of subtraction is addition. So I'm going to add 7 to both sides. Okay. So this becomes 5 times e to the negative x equals 9. Okay. Then continuing, next would come multiplication. So since this is times 5, the inverse of that is to divide by 5. Okay, and so this would be e to the negative x equals 9/5. Okay. And then, okay, in the previous lesson, when we wanted to get the x by itself, we would take the log of both sides here, right? But because our calculator does have a natural log sign, we're going to take ln of both sides. Okay, so I'm going to take the ln of this side, right? Because this is log base e, right? And so if you think about it, e to the what power would give me e to the negative x. That would allow these to cancel, right? Because e to the negative x power gives me e to the negative x. So then that's negative x. That's solved for that exponent. Equals ln of 9/5. Okay. Then I would just want to get rid of the negative by either multiplying by -1 or dividing by -1. And so this would give me x equals negative of natural log of 9/5. Okay. Don't forget we're taking the natural log of this whole thing. So when you enter in the calculator, make sure you have those parentheses. Okay. So I'm going to type it into my calculator now. Okay. And then that gives me approximately negative 0.5878. Okay, so 10,000th place, 10th, 100,000, 10th, so 4 decimal places. So x is approximately negative 0.5878. And there you go. Okay, so why don't you try CYP 4a on your own and come check your answer when you're done. Okay, you should have gotten x is approximately negative 0.4055. If you got that right, you can move on to the next example. If not, here is your explanation. Okay, so going reverse order of operations, I'm going to get rid of the plus 2 by subtracting 2 on both sides. Okay, that leaves me with 3 times e to the x equals 2. Then get rid of my multiplying 3 by dividing by 3 on both sides. That gives me e to the x equals 2 over 3 or 2/3. Right? Then to get rid of the e, I'm going to do the natural log of e, or natural log, so ln. Okay. So remember, when we're solving logs, just finding the exponent, right? It's asking you e to the what power gives you e to the x. Well, e to the x power gives me e to the x, right? So that's why in some ways of thinking about it, they cancel, and that leaves you x equals ln of 2/3. Type that in my calculator, and that's what I get. Okay, now we're moving on to example 5. So here, what we're going to be doing is we're going to be using the compounded continuously formula, and that is here in the book. So when interest is compounded continuously, the amount A in an account after t years is found using the formula A equals P times e to the RT power. P is the amount of principal, or what you're starting with, and R is the annual interest rate expressed as a decimal. So here with example 5, it says, suppose you deposit $1,000 in an account paying 2.5% annual interest compounded continuously. Okay? So here we're going to write our formula. So again, it's A equals P times e to the RT power. Okay? This here tells us that we deposited $1,000 in here, so this is going to be our principal. Okay. It tells us that it pays an interest of 2.5%, so that's going to be our rate. Okay. And then here, it wants the balance after 10 years, so t equals 10. Okay. So I want to know the amount. So A equals my principal, what I started off with is $1,000. E, the 2.5%, I need to rewrite it as a decimal, solely as a decimal, so that's going to move that decimal several places to the left, so this will be 0.025, so that is my rate, and then my time in this case is 10 years. Okay. So here's my that, and here's my rate. Okay. Important of how we enter it in the calculator, so either using parentheses or doing it step by step, it's up to you. So 0.025 times 10, okay? Then that gives me 0.25. Okay, so e to the 0.25. Okay, and then I'm going to times 1,000. And this gives me $1,284.03. Okay. Money in America has 2 decimal places, so the amount is approximately $1,284.03. And there you go. Okay. The next question asks, how long will it take for the balance in the account to reach at least $15,000? Okay. So what I want is for this to be at least this. So 1,000 E 0.025 times T. I want it to be at least this, so it has to be greater than or equal to 1,500. Okay? So I'm going to do several things. So the first thing I'm going to do is get rid of the times 1,000 by dividing by 1,000. This gives me e to the 0.025 t is greater than or equal to 1.5. Okay. Then I'm going to get rid of the e by doing natural log, so I'm going to take the natural log of both sides. Okay. So then this will give me 0.025 t is greater than or equal to ln of 1.5. Again, I'm going to enter it all later. Okay. Then, since this is connected by multiplication, I'm going to get rid of it by dividing. Okay. And so then the time greater than or equal to ln of 1.5 divided by 0.025. Okay. So now I'm going to enter it in my calculator, ln of 1.5. divided by 0.025, and that gives me 16.2 blah 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 blah. So the book chose to round it to 2 decimal places, so I'll just do that. So time greater than or equal to 16.22. Okay, so it will take at least, well, it's a little bit less than that, but at least 16.22 years, so that it ends up being 15,000. Okay, and there you go. So why don't you try CYP 5A and 5B, and once you're done, come check your answer. Okay, so for 5A, you should have gotten $5,809.17, and for 5B, you should have gotten, it will take at least 11.22 years. Okay, if you got that right, you can move on to the last example. If not, here is your explanation. Okay, so here I know that 5,000 is my starting amount, so that's here for the principal. 3% represented solely as a decimal is 0.03, so that's my R. And then here, since the time is 5 years, that's my T. Okay, enter it all into the calculator, and then that's the answer I get. 5B this time, I want the amount to be greater than or equal to 7,000. So again, principal 5,000, E, the rate 0.03 T. I'm finding T this time. I want the amount to be greater than or equal to 7,000. Right? So first, since it's connected by multiplication, divide by 5,000 on both sides. That leaves me with the 1.4 on the right. Okay. Get rid of the e by doing natural log on both sides, so ln on both sides. That leaves me with 0.03t, and then ln of 1.4. And then, since this is connected by multiplication, get rid of it by dividing. So then I get this. To enter this into my calculator, I get approximately 11.22, and so that's why it will take at least 11.22 years. Okay. So the last part is to solve natural log equations and inequalities. Okay? So here I have ln of 5x equals 4. So what I'm going to do is I want to get rid of the ln first. Okay, so what I'm going to do, the opposite would be to do that power, right? So I'm going to do e to the ln 5x equals e to the fourth. Okay. So this gives me 5x equals e to the fourth. Then, since this is connected by multiplication, I'm going to divide by 5 on both sides. This gives me x equals e to the fourth divided by 5. So then in my calculator, I just need to find what e to the fourth is, and then divide that by 5, and then I get approximately, rounding to the nearest 10,000, so 4 decimal places, x is approximately 10.9196. There we go. Okay. Okay. So same thing on the other side here. I want x by itself. Right now it's still connected to a -1 and a natural log. Okay, so here I need to get rid of the natural log before I deal with the grouping. So to get rid of the natural log, do to the e. Okay, these cancel out, leaving me with x minus 1 is greater than e to the negative second. And I'm going to add 1 on both sides. So x is greater than e to the negative second, and then whatever that is, I'm going to add 1. Okay, so again, you can't combine these, right? This isn't e to the negative, e to the first, right? So not connected, not combinable, or whatever you want to call it. So e to the negative second, find what that is, then I'm going to add 1, round it to 4 decimal places. So x is greater than 1.1353, right? And here, for both of these, I don't have to worry about them being a negative and not working, because this positive times a positive is a positive. Okay, and here even 1.1353 minus 1 will still be positive. So there you go. Okay, so why don't you try 6a and 6b, and once you're done, come check your answer. Okay, so for 6a, you should have gotten x is approximately 365.5444, and for 6b, you should have gotten that x is between -2/3 and 48.804. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So to get rid of the ln, I do to the e. Okay. That leaves me with 3x equals e to the 7th. Since this is multiplication, get rid of it by dividing. So x is e to the 7th divided by 3. Enter that into my calculator, and this is what I get. Okay. For 6b, same thing. To get rid of the ln, e and e. Right. This leaves me with 3x plus 2 less than e to the 5th. Get rid of the plus 2 by subtracting 2 on both sides. Again, you can't combine these. It's not e to the 3rd, right? Because this isn't, yeah. Okay. Then, since this is multiplication, get rid of it by division. So x is less than e to the 5th minus 2, and then all divided by 3. So that gives me this. Okay. Where did the -2/3 come from, right? So if x is smaller than this, what I need to worry about is that when x gets too small, that this will become negative. Okay, so then I need to make sure that this is greater than 0. Okay, which means that x would have to be bigger than -2/3, because -2/3 would make it 0. Okay, and so that's why it's like that. Okay, so that's it for today. Have a great rest of the day. Bye, guys.